Hello viewers and my dear students. We'll continue this projection of points, and this is session 3 on projection of points, where we are doing the concepts about RPP, LPP and all that. Just see, now there is a problem here. A point A is 20 mm above HP, 30 mm in front of VP and 25 mm from LPP. There are projections of this point. Now I have given LPP. That means on LPP, as you know, you should get the right view on LPP. Okay. 20 mm above HP means it is parallel to VP. This distance has to be projected on VP. 30 mm in front of VP means it is the distance parallel to HP and it should be projected on HP. Okay. This basic thing you should know. Okay. Now you see here. You make ready XY, X1, Y1, right? You make it ready. I have made this, since this problem LPP has been given. I made this as VP, HP, LPP. I made it ready. Okay. Draw 45-degree line also. Make it ready so that it will be easy for you to work. XY, X1, Y1, VP, HP, LPP. You do. Okay. Now you see it. As soon as you get this, you know very well this 20, what you've seen on HP, sorry, what you've seen on VP is the distance above HP. Distance above HP is parallel to VP. As a result, it should be projected on VP. Okay. This will actually be the dashes, P dash or Q dash or whatever it is. Okay. It is the front view. And this is 30 mm is what? It is the distance in front of VP. Okay. It is the distance in front of VP. The distance of in front of VP is parallel to HP and is seen on HP. That is why this will be the top of the point. And this is 25 is the distance from LPP they are given. That is why take 25 and make a line here. At 20 you make a dot. At 30 you make a dot. Okay. Then you see here A dash, A is the point. A dash is the front view. A is the top view. Okay. Then you take the projectors in this way. You get A double dash. That means this problem, as soon as you look at this, it is clearly the point is A, is located in the space. How it is located in the space? That is, it is located in the space between VP, HP and LPP. It is located in the space. The location distance is, it is actually 20 mm above HP. Okay, 20 mm above HP, 30 mm in front of VP and 25 mm from LPP. This is the problem. Now how you do is, first 25 mm LPP from X1, Y1 line, you draw 25 and 20 mm above HP, no? At 20 mm from XY line, you put A dash. Then 30 mm in front of VP, no? 30 mm is in front of VP, parallel to HP. That is why 30 mm in front of VP, that is parallel to HP and is seen on HP. Make A here. Okay. A and A dash are over. Then A double dash, as I said here, you take a projector here. Whatever is the distance in front of VP should be actually this. In order to transfer this distance 30, we will have a mechanism here. You draw 45-degree line. Automatically it becomes a square here. If this is 30, this will be 30. Once this is 30, since it is an imaginary square 45-degree line, this will be 30. This will also be 30. In that way, this problem gets over. The problem clearly says it is a point A which is 20 mm above HP, 30 mm in front of VP and 25 mm from LPP. Draw projections and the problem has been completed in this way. That is why it is right side view are given, the same as problem 18 in VTU textbook. Okay. VP, HP, LPP is that. Since it is view on LPP, it's the right view or right side view which is on LPP, that you should know. Okay. Now you see here point A is 20 mm above HP and 50 mm from RPP. Okay. Now VP, HP, RPP they are given. RPP. The shortest distance of this point from the intersection of HP VP is 40 mm. Okay, please follow. Here a problem is slightly twisted. You should know to this level. Draw projections of this point and find the distance of the point in front of VP and all that they are given. You just see. Point A is 20 mm above HP. That means this 20 mm above HP anyway is projected on VP. Okay. Now you see here. First, you understand the concept here. You understand the concept here. VP is this. HP is this. RPP is this. Okay. And point is here. The point is here. It is actually 20 mm above HP. Okay, 20 mm above HP. This point is 20 mm above HP, and it is 50 mm from RPP also. 50 mm from RPP. But the distance in front of VP, this distance they are not given. This distance they are not given. But instead, they are given the shortest distance of this point from the intersection of VP and HP. That is from XY line. Okay, this is VP HP. Shortest distance from the intersection of VP HP they have given. That is how much it is? 40. Please understand, any shortest distance problem given, okay, any shortest distance problem given, see this is 40. I think you can understand, no? The point is here P. This is 20 mm above HP they are given already. 50 mm from RPP they have also given. But what exactly is the distance in front of VP? Okay, they are not given. In fact, they have asked you to find that. That is X is the distance to be found out. But instead of giving this distance, they are given the shortest distance. The distance, the shortest distance of this point from the intersection of VP and HP is 40. That means the shortest distance is this distance. Can you understand? From the intersection of VP HP means from XY line you take. This 40 mm is this. Okay, the shortest distance of this point from the intersection of VP HP is 40 means this. Please understand, any shortest distance problem, this 40 mm, don't you think it is parallel to RPP? And this 40 mm will be this 40 mm. Can you understand? Where you locate P double dash. Okay, this distance anyway is 20. This distance anyway will be 20. But this distance of 40 mm is parallel to RPP. As a result, this 40 mm can be seen in its true length, that is actual length, in the RPP. This you should never forget. So many problems of this category you will do later on also. Any shortest distance from the intersection of HVVP means this distance. This will be seen in its actual length, 40 mm only, in RPP. Okay, this you should know. Okay, now what do you do? Okay, draw XY line. Draw XY line, draw X1, Y1 line. VP, HP, RPP you do. Okay. Okay, now they are given from RPP it is 50 mm. You take 50. Okay. Take 50. And since it is given 20 mm above HP, 20 mm above HP also, A dash also you plot. Okay. I have told you the shortest distance of 40 mm, whatever they are given, can be seen on RPP. Okay. You see here, again I show you this. The shortest distance 40 mm can be seen on RPP. This is RPP. Can be seen on RPP. And directly wherever you cut that, you should get the side of the point. Okay. That's why, see here, XY, X1, Y1, VP, HP, RPP I made it. This is 50, A dash you take. This is 20 mm above HP. Then you take the projectors here. As I've said, the shortest distance can be seen in its true length in the side view. That is why you origin as center, 40 mm as a radius, cut on the projector. Wherever it cuts, you get A double dash. That is the side view of the point you get. Okay, please follow. This is the side view of the 40 mm. How you see here? You see here, this is 40. And the same 40 is seen from here. That means at the origin, that means at the intersection of XY and X1, Y1 line, from here as center, you can cut 40 to get the side view. Okay, this 40 and this 40 are same. This is, we call it as origin in fact. Front view, that is VP, HP, RPP, common point is this. This we call it as origin. Origin as center, 40 as the radius, you cut it to get directly the side view. Okay. Now you see XY, X1, Y1 line, you draw, make it ready. Okay, 50 you take, A dash you take, that is 20 mm. Then origin as center, on this end projector, as I just now said, for 40 as the radius, cut here. You directly get A double dash, which is the side view of the point A. Then you take the projector down and go here in this way. Okay, and take a projector from here also, and this is the distance in front of VP. In fact, that is the distance to be found out. You find out that distance to be X. X is the distance in front of VP. That will be 34 mm. If you actually measure and you know 45-degree line and all that we are done. Okay, if this is 34, actually this distance will also be 34. but don't worry about that. How you done, I'll repeat. XY you take, X1, Y1 you take, 50 mm you take from here at this, draw a thin line. Okay, 20 mm above HP has been given. You make A dash, you fix it. Okay, at 50, you A dash, you fix it. Once you fix it at A dash, draw a projector from A dash, origin as center, shortest distance, whatever shortest distance they are given, that as the radius, cut on the projector, you get A double dash. Then draw projector down, meet the 45-degree line, and go this way, meet and draw the projector from A dash also, you get A. This is the distance of the point in front of VP. Actually, this was in fact asked. It had not been given in this problem. Okay, you find X, which is the distance in front of VP, that is 34 mm. If you are done correctly, all should get the same answer. This is 34 and 39 in VTU textbook. It will be the same problem. Now, projection of points in the second quadrant. Okay, I just introduced the second quadrant. See here. Here, you see here, the second quadrant is this. Your front view direction is this. Top view direction is this. Right direction, left direction, all that, let it be there. It is same thing. Now, once it is this direction, the points are located in this space. This is second quadrant. That means the points or plane surface or whatever it is, objects are located here. That means when your front view direction is this, it is the objects or points located behind VP, above HP. Can you understand this? Okay, behind VP and above HP is the thing. That is why what you do is behind VP and above HP, if they give, immediately you should come to conclusion it is the second quadrant problem. That is why then XY line is this, HP VP, XY line, VP HP you merge here. That is above XY line you get VP HP, both front view and top view you get it only here only. Okay. Now if you see here, the problem is point is 45 mm above HP, 60 mm behind VP and 30 mm from RPP. Okay. That is why above HP behind VP, it has clearly told you that it is a second quadrant problem. Above HP behind VP. Okay. Okay. Above HP behind VP, because you are looking from here. Above HP behind VP will tell you that it is a second quadrant problem. XY VP HP, you make it ready. Now in this problem, XY VP HP, since RPP has been given, RPP you make it ready. Now you see here, I made two dots. See here, this is 45 means it is the distance above HP, because any distance above HP will be parallel to VP and is seen on VP and it should correspond to front view distance. That is why P dash you do. Then it is behind VP 60 mm. Behind VP, any distance behind VP is parallel to HP and it will be seen as a two length in HP and it will give the top view distance. I'll repeat, above HP is front view distance, behind VP is top view distance. That's why P and P dash you got. This is 30 mm from RPP, right? And also you know very well, front view and the side view should be on the same end projector, because if it is above HP is 45 and your P double dash should be on the same projector. In that way, you meet the 45-degree line and come down, okay, come down and take a projector from here. This will be P double dash, okay. And if you're done correctly, the distance behind VP, no, this is 60 mm, that distance will be this also 60 mm only it will be, okay. And always see that front view and the side view, the distance above HP will be same for front view and side view. That is why this 45 means this will also be 45. And when you meet 45-degree and come down or come up, sometimes this and this should be on the same projector. Now you know very well, it's a second quadrant problem. Problem 16 from VTU textbook. As soon as you look at this problem, you say it is 45 mm above HP, 60 mm behind VP, 30 mm from RPP, and you are supposed to write the projections of this point P in all the three quadrants. P, P dash and P double dash has been written. Okay. Now we come to the end of session 3 on projection of points. Thank you viewers for watching. Thanks again. Thank you.